This is Bob Capetta from the University of Illinois Chicago, and this lesson is on graphing the secant and cosecant functions. So our first example is cosecant, which is the reciprocal of sine. So knowing that, we're going to first graph the sine function, and then we're going to use that to help us graph the cosecant function. Now how do we graph the sine? We remember the unit circle. The sine is the y values. At 0, sine is 0. At pi over 2, the y value is 1, sine is 1. At pi, the y value is 0, sine is 0. At 3 pi over 2, the sine is negative 1. And back at 2 pi, the sine is 0. So we know all of those things, except we don't want sine, we want cosecant. Take reciprocals. Reciprocal of 0, undefined. We'll have an asymptote. Reciprocal of 1 is 1. Reciprocal of 0, undefined, another asymptote. Reciprocal of negative 1 is negative 1. Reciprocal of 0, another asymptote. So for the cosecant function, asymptote at 0, and at pi, and at 2 pi. So that's certainly a good place for us to start, and then we know the behavior at pi over 2 and at 3 pi over 2. Cosecant of pi over 2 is positive 1, because the reciprocal of 1 is 1. Cosecant of 3 pi over 2 is negative 1, because the reciprocal of negative 1 is negative 1. And I'm just going to add a few more points. I'm going to add the points where the sign is a half or negative a half, because the reciprocal of a half is 2. The reciprocal of negative a half is negative 2. So sine of pi over 6, first quadrant, is a half. 5 pi over 6, second quadrant, is a half. 7 pi over 6, third quadrant, sine is negative, negative a half. 11 pi over 6, fourth quadrant, negative a half. So reciprocal of a half is 2, a half is 2. Reciprocal of negative a half is negative 2. Reciprocal of negative a half is negative 2. So I have, what, 1, 2, 3, 4, 5, 6 points I can graph, as well as 3 asymptotes. That should give me an idea of what the cosecant function looks like. Here is sine. Now what do we know? If I'm going to graph cosine, any place where sine is 0 has no reciprocal. I will need an asymptote at 0. I'll need an asymptote at pi. I'll need an asymptote at 2 pi. That'll be good for me to know. Plus I had all of those points we looked at. So there's my 3 asymptotes. And there's the 6 points I gave you. So if I want to graph cosecant, I'll start at the peak, go through that point and towards the asymptote. Peak through the point towards the asymptote. Peak through the point towards the asymptote. Peak through the point towards the asymptote. So we're going to get 2 pieces to the cosecant function on the interval from 0 to 2 pi. That'll look like this. So you can see that's going through those 3 points, but always starting at the peak, heading towards the asymptote. And we can remove the sine function if we want to. And we can see that this is what the cosecant function looks like. But I always like to think of the cosecant in reference to sine. Start with sine, go from peak to asymptote, so that your result looks something like this. For cosecant, cosecant, the reciprocal of sine. Now our second function here is secant. Secant is the reciprocal of cosine. Cosine are the x values on the unit circle. So at 0, cosine is 1. Pi over 2, cosine is 0. Pi, cosine is negative 1. 3 pi over 2, cosine is 0. 2 pi, cosine is 1. Let's look where cosine is 0. That's where we will have our asymptotes. So the secant of pi over 2 does not exist. That's undefined. Asymptote at pi over 2. 3 pi over 2, the same thing. Asymptote there. And then we have our values where cosine is 1 and negative 1, and the reciprocals are easy. Now when is cosine a half? Cosine of pi over 3 is a half. So I'm going to use pi over 3 in all 4 quadrants just to give me a few more points to help me construct my first secant function. So pi over 3 in the first quadrant, cosine is a half, reciprocal of 2. In the second quadrant, that's pi minus pi over 3, 2 pi over 3. Cosine is negative in the second quadrant, negative 1/2, reciprocal is negative 2. In the third quadrant, cosine is still negative, pi plus pi over 3, 4 pi over 3. Cosine is negative half, so reciprocal is negative 2. Fourth quadrant, pi over 3 short of 2 pi, that's 5 pi over 3, cosine is positive, reciprocal of 1/2 is 2. So now I have, what, 2 asymptotes, 1, 2, 3, 4, 5, 6, 7 points to work with to construct this secant function secant reciprocal of sine. But I start with cos. Where do I have asymptotes? Wherever cos is 0. Cos is 0 here. Cos is 0 there. Start at the peak, head to the asymptote. Start at the peak, head to the asymptote. Start at the peak, head to the asymptote. And those extra points will give me an idea of what the shape of that graph looks like. So here are those 7 points. 1, 2, 3, 4, 5, 6, 7 points. There's the asymptotes where cosine is 0. So again, starting at the peak, heading up to the asymptote, peak, asymptote, asymptote, going through the points, of course, peak through the point, asymptote. What will this graph look like? This is the graph of secant. There you can see the graph of secant together with the graph of cosine. That's the first period of the secant function from 0 to 2 pi. And if I remove that cosine function, now you have the graph of y equals sec x, or f of x equals sec x. Now let's look at a situation like this where we're going to have several cycles, cosecant of 4x. We've got to start with sine of 4x and then just play our same game, go from peak to asymptote from there. So what do we know about sine of 4x? 4 cycles from 0 to 2 pi. 4 cycles, 0 to 2 pi, dividing by 4. What will we say? 4 divided by 4, 1 cycle. 2 pi divided by 4, 2 pi divided by 4, or pi over 2. So the first cycle goes from 0 to pi over 2. Starts at 0, ends at pi over 2. Midpoint, pi over 4. Halfway point from the start point to the midpoint. In other words, the first quarter point. 0 to pi over 4, halfway is pi over 8. And then from pi over 4 to pi over 2, halfway there is 3 pi over 8. But we know what sine does. It starts at 0, goes up to 1 at the quarter point, back to 0 at the midpoint, down to -1 at the quarter point, and then 0 at the end point. We know that. So we can kind of keep that in mind. This will be 0, 1, 0, -1, 0 at these values. But I need an amplitude of 2 because there's a 2 here. So instead of sine, I need twice the sine. So that'll change everything to 0, 2, 0, -2, 0. We cannot forget the amplitude. So doubling the sine, this will be our values for twice the sine value. So from our start function, twice the sine is 0. At our first quarter, twice the sine is up to 2. Midpoint back to 0. Next quarter point down to -2. And point 0. So these are the points I put into my software to actually graph. And that's what it looks like. Starting point, quarter point up to 2, amplitude is 2. Midpoint at 0. Quarter point down to -2. And point back to 0. So how many of these cycles will I get between 0 and 2 pi? If we count them, 1, 2, 3, 4 cycles between 0 and 2 pi. But it was sine 4x, so that shouldn't surprise us. But that's not our final graph. We wanted to cosecant 4x. So we've got to play our game where we draw in all of our asymptotes to see how that's going to behave. So all of those asymptotes, wherever sine of 4x is 0, asymptote here, 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 etc. Those are all the values. And you can still see the original 5 points that I had. But wherever sine 4x has an asymptote, excuse me, whenever sine 4x is 0, cosecant of 4x needs to have an asymptote. And then all we do is we go from the peaks for the cosecant function, go from peak to asymptote. Peak to asymptote, peak to asymptote. So the graph in black is 2 cosecant 4x. If I want to remove the sign, you can see there's our graph for y equals 2 cosec 4x. Let's do one more here. What if I have y equals the secant of x minus pi over 4 plus 3? Let's first go ahead and graph y equals sec x. But how are we going to get that? We're going to do cos x and then go peak to asymptote. So let's quickly do that. So this is the graph of y equals cos x. At 0, it's 1. Then it's 0 at the quarter point, down to -1 at the midpoint, 0 at the third quarter point, and back to 1 at the end point. So 0 yields 1, 2 pi yields 1, and then pi yields -1. Now, if we're going to go ahead and shift everything, we're going to shift it pi over 4 to the right and 3 up. Let's go ahead and graph that function. I think I changed my mind actually. Here's the graph of cosine. Let's graph secant first, and then we'll do our shift. So we see all of these values. This graph in orange is the graph of secant. So what do I want to do? I want to move every point pi over 4, so that's one box over, and then 3 up. Move it up 3. So what will those points look like? Moving all of those, every point up over pi over 4, up 3. So I've taken this point, moved it over pi over 4, and up 3. So this peak then has to go up to the asymptote, up to the asymptote. This peak, which is the one that's going down, I moved over pi over 4 and up 3. That's got to go down to the asymptote, down to the asymptote. You'll notice I moved the asymptote over. Right, so each of the asymptotes was also moved over. This asymptote is moved over. It's now in red, and the blue asymptote has been moved over. Then I took this peak over 1, up 3, and that's got to go back to the asymptote. So visualize this, these upper peaks going up to the asymptote, going up to the asymptote. This lower peak going down to the asymptote. So let me go ahead and erase the original functions and just show you the asymptotes and those 3 points so we can visualize this. From here up to the asymptote, from here down to the asymptote, from here up to the asymptote. You could have used more points if you want, but frankly I think it's just going to get confusing. So now let's put the whole thing together and see what that's going to look like. That's secant x minus pi over 4 plus 3. And here that graph is, and you can see each of those 3 points indeed was a peak, and then the curves head up to the asymptotes. And that will conclude this lesson.